Hi everyone, I'm Keith Mittman. I'm a fourth-year PhD student at Caltech, and my research group has recently come out with some really interesting results regarding black holes. So we know that black holes in nature will orbit each other and eventually merge into what's called a remnant black hole that's highly distorted. And so this remnant black hole, because it's distorted, will ring down to a steady state. And for years, people have tried to model this ringing using what are called linear terms. And what we show is that by including nonlinear terms, you actually can model the waveform from this black hole merger much more accurately. And so this difference between linear and nonlinear is actually what makes nature really interesting. So for example, if you and a friend are on a trampoline and you both bounce very gently, then you're not going to feel each other's bounces. But if one of you starts to bounce very aggressively, then the trampoline is going to react to that bouncing and everything is going to get more chaotic and violent. And that's exactly what these nonlinearities are. They're small amplitudes interacting with each other to create something more chaotic. And so the reason this is so interesting for gravitational physics is because now that we know that black hole ringing is nonlinear, we can much more accurately understand Einstein's theory of relativity and therefore better understand these mergers that we see occurring in nature all around us.